Hi dears, we'll start with exercise 5.1. We need to prove the f of x, the given function f 5x minus 3 is continuous at x is equal to 0, at x is equal to minus 3 and at x is equal to 5. So for these three subdivisions we need to prove the given function is continuous. So for proving continuous we should know the property that limit x tends to c f of x equal to f of c. So this is the definition or the property we should know for proving this continuous function. We will start with x is equal to 0. We will do the LHS one. So LHS is limit x tends to c, that is x tends to 0, c is generalized f of x, and f of x will substitute the given function. Till you substitute the limit value, you should write this one, 5x minus 3, and in place of x we need to substitute this limit. Here we have the value 0, so 5 into 0, 0, 0 minus 3 is minus 3. This is LHS 1. RHS, we have f of c, that is f of the x value. So f of 0 is equal to, directly substitute in the function, so 5 into 0 minus 3. So 5 into 0, 0 minus 3, we get minus 3. LHS and RHS value are equal, that is limit x tends to 0, f of x equal to f of 0. Since both the values are same, the given function is continuous at x is equal to 0. The same way we do it for minus 3 and 5. Now for x is equal to minus 3 will do. Same way the LHS we write here, instead of 0, instead of c in general definition, we'll write it as minus 3 f of x. In place of x we need to substitute minus 3. So limit x tends to minus 3 and write the function 5x minus 3. In place of x substitute minus 3. So 5 into minus 3 is minus 15, minus 15 minus 3 is minus 18. And RHS is direct value substitution, that is f of minus 3, 5 into minus 3, minus 3, that is minus 15 minus 3, it is minus 18. The values are equal, therefore limit x tends to minus 3 f of x equal to f of minus 3. Therefore the function is continuous at x is equal to minus 3. Last subdivision, at x is equal to 5, we have limit, the LHS will do first, limit x tends to 5 f of x, that is we'll substitute the function, limit x tends to 5, the function is 5x minus 3 and in place of x it is 5, so 5 5s are 25, 25 minus 3 it is 22, and RHS it is direct substitution, that is f of 5, that is again 5 into 5 25, 25 minus 3 is 22, the values are same, therefore limit x tends to 5 f of x equal to f of 5. Therefore, the given function is continuous at x is equal to 0, at x is equal to minus 3 and x is equal to 5. Therefore, the function is continuous. We need to examine the continuity for the given function f of x equal to 2x square minus 1 at x is equal to 3. We will use the same definition to check whether the given function is continuous or not. The LHS 1, let us write the definition first of all. Limit x tends to c, f of x equal to f of c. So this is the definition. In LHS what we are going to do? Substitute the value. So limit x tends to 3, f of x will be, substitute the function. So limit x tends to 3, in place of f of x it is 2x square minus 1 and in place of x it is 3. So 2 into 3 square minus 1, 3 square 9, 2s are 18, minus 1, 17. And for RHS, we directly substitute in the function, that is 2 into 3 square minus 1 again, 3 square 9, 2s are 18 minus 1, 17. Therefore, limit x tends to 3, f of x value is equal to f of 3. Therefore, the function is continuous at x is equal to 3. Number 3, we need to check whether the given function is continuous or not. Before working out these questions, just remember the polynomial functions, the quotient functions are all always continuous, except for quotient function denominator we need to check which value if we substitute for that variable will become 0. So except that value the given function is continuous elsewhere. Okay, why we are saying? Because denominator if we have 0 then that will be as infinite or does not exist, isn't it? So we should not get the denominator value as 0. So only for quotient function you need to check which value if we substitute it will become 0. Otherwise for all the values it will be continuous. Since the first subdivision x minus 5, if you check with the degree it is a positive whole number, that is the polynomial function. Therefore the function is continuous. Okay, the function is continuous as the given question, or you can write as the given f of x is a polynomial function. So by default we can conclude polynomial functions are continuous. Okay, and for the second subdivision it's a quotient function, that is it is in the form of a fraction, isn't it? So for x minus 5, if we substitute x as 5 alone, the denominator becomes 0. Therefore the function is continuous everywhere except x is equal to 5, because when we substitute 5, then that will be 0. Denominator should not be 0. So except at x is equal to 5, all other values the function will be continuous. You need not to work out the definitions and all. If it is polynomial or quotient, check with the denominator part and you conclude it. Okay, and for the third subdivision it is similar to second subdivision, but if there is a way to simplify then write. Okay, so x square minus 25, this 25 we can write it as 5 square. Then a square minus b square, we know the formula, a plus b into a minus b, that is x plus 5 into x minus 5. As it is a product, we can cancel as a whole x minus 5. The left out is x plus 5. Like the first subdivision, we can conclude the given is a polynomial function, and for a polynomial function, the function is always continuous. And for fifth subdivision, what we need to do is, you would have learned what is modulus function in class 11 itself, isn't it? So we know the general definition. Modulus x is x when x is greater than or equal to 0 minus x when x is less than 0. This is for the general modulus x. Here we have x minus 5. To find this value, just equate to 0. So x minus 5 equate to 0, equal to 0. When we remove the modulus, right side it will be plus or minus. As it is 0, we don't need to worry about the signs. It is just 0. When we take minus 5 to the other side, it will become plus 5. So similar to this function, we can write modulus of x minus 5 can be written as x minus 5 when x is greater than or equal to 5, as we have found this value, minus of x minus 5 when x is less than 5. Here we use the left hand limit, right hand limit, that is left hand limit, limit x tends to a minus f of x, right hand limit, limit x tends to a plus f of x equal to f of a. These three values should be equal. Then only we can say the function is continuous. That is, for a particular number, the left hand approaching, the right hand approaching, and at that point the value should coincide. Then only we can say the function is continuous. Okay, now we'll do left hand limit will be, here just draw the number line in the rough column. So we have 5, isn't it? So left side, right side. Left side it will be less than 5. That will be the function for the left hand limit. Either you can have minus of x minus 5, or you can multiply this x minus inside, so that will be 5 minus 6. So we'll mention left hand limit. Okay, limit x tends to 5, power this minus and plus you need to mention to indicate minus for left hand limit, plus for the right hand limit, f of x, and here the function for left hand limit is less than 5, minus of x minus 5, or you can multiply minus inside, so it is 5 minus x. When you substitute 5 in place of x, it is 5 minus 5, 0. Right hand limit we need to represent in the power as plus, and we need to write the function. So limit x tends to 5 plus, the function is x minus 5, and when you substitute the value in place of x, it is 0. F of 5, because x value is 5, isn't it? For that we'll use the modulus value. So x minus 5, that is 5 minus 5, 0. Modulus of 0 is also 0. If you check with the value, all the values are equal, that is left hand limit, right hand limit, and f of that particular number. All three are same, therefore the function is continuous. Number 4, we need to prove f of x equal to x power n is continuous at x is equal to n, and n they have mentioned as positive integer. We can make use of the definition, that is limit x tends to c, f of x equal to f of c. We can make use of this definition. Now the LHS part, LHS is limit, they have given at x is equal to n, isn't it? So limit x tends to n, f of x, substitute the function, they have given as x power n. In place of x, we need to substitute n, so it is n power n. Don't substitute in the power, many will be substituting in place of the n, but we need to substitute in place of x, so it is n power n. And the RHS side, that is f of n, f of x is x power n. When we substitute n, again we have n power n. As LHS and RHS are equal, we can conclude limit x tends to n, f of x equal to f of n. Therefore, the given function is continuous at x is equal to n. Question number 5, we need to check the given function. They have defined x if x less than or equal to 1, 5 if x greater than 1 is continuous at x is equal to 0, 1 and 2. Okay. First of all, draw a clear number line either in your rough column or in the main space, nothing wrong, minus infinity to infinity. They have given the value 0, 1, 2. Okay. And here it is defined for less than or equal to 1. So, less than or equal to 1, the function is x, that is the left hand side, and greater than 1, that is the right hand limit function we will use, it as 5. So, for greater than 1 to infinity, the function remains the same. For 1 to minus infinity, the function remains the same. Okay. So, if it is less than 1, for 0, for both left hand and right hand limit, it will be the same. For 2, both left hand and right hand limit, the function remains the same. So, for 1 only, the left hand is x, right hand limit, the function will be 5. Okay, that alone we need to be clear. Now, we will do it for x is equal to 0. As I mentioned earlier, from here 1 to left side minus infinity, the function remains the same. So, minus for 0, the left hand and right hand and at function, the same function will be using. Okay, limit, this is LHL. Limit x tends to 0 minus f of x, the function is x. So, limit x tends to 0 minus, the function is x. Substitute the x value, it is 0. Right hand limit, the same function, limit x tends to 0 plus f of x is equal to, it should be power, okay. Limit x tends to 0 power plus x. Again, when we substitute x as 0, it will be 0. And f of 0 again the same function, that is x, 0. All the three values are same. The function is continuous at x is equal to 0. So, the first part is over. Now, we need to check for the second part, that is for 1. X is equal to 1. The left hand limit, that is limit x tends to 1 power minus f of x. Here, for 1 left hand limit is x. So, limit x tends to 1 power minus x. Substitute the value, it is 1. Right hand limit, for 1 right hand limit is 5. It is like a constant function. So, limit x tends to 1 power plus f of x equal to limit x tends to 1 power plus 5. Here we don't have any variable to substitute. So, the answer will be the same, 5. When you check the values for left hand and right hand limits, the values are not same. Here itself we can stop. We don't want to find what is f of 1. Since the LHL and RHL is not the same value, the function is not continuous at x is equal to 1. We can immediately conclude the function is not continuous if LHL and RHL value are not same. Okay. At x is equal to 2, the last subdivision, for 2 if you check the left hand, right hand and at the point the function is same. The limit LHL will do limit x tends to 2 power minus, the function is 5. We don't even to substitute because it is a constant function. And RHL, if you see the same function, limit x tends to 2 power plus f of x is equal to 5 and f of 2 was also 5. As all the three values are same, the function is continuous at x is equal to 2. So, therefore, the function is continuous at x is equal to 0, at x is equal to 2 and not continuous at x is equal to 1. So, drawing the number line will help you even more better. We need to check this point of discontinuous any. Okay, if you have like this straight away, check with the numbers what they have given. For that particular number, less than and greater than should be there. Then only we can do the left hand and right hand limit. Immediately plot the number line. The only value here it is mentioned as 2. So, less than the left hand limit, that is 2x plus 3, and right side that is greater than 2, it is 2x minus 3. So, RHL function, LHL function. So, wherever you have the equal, that is less than or equal to or greater than or equal, any one only it will be there. So, that function will use it for f of 2. If we suppose instead of here you have x greater than or equal to 2, then we will choose this function as f of 2 for substituting directly. Okay, that also we need to have it in mind. Okay, let us do the LHL. LHL is limit x tends to 2, the number is 2 here, be careful with that also, f of x, and the function is 2x plus 3. So limit x tends to 2 power minus, the function is 2x plus 3. When we substitute x as 2, so 2 into 2 plus 3. Whenever you are substituting the value, you should not write the limit. Till you substitute, you should mention limit. Okay. 2 2s are 4 plus 3, 7. And right hand limit, it is limit x tends to 2 power plus f of x equal to limit x tends to 2 power plus, we found the RHL function is 2x minus 3. When you substitute x as 2, 2 2s are 4, 4 minus 3, it is 1. We don't even want to proceed with f of 2 as the values are not the same. Since LHL is not equal to RHL, the function f of x is not continuous at x is equal to 2. Continuity if any, and we have the functions. Here if you see, for minus 3, x less than or equal to minus 3 and x greater than minus 3. Both are defined. For 3 also, x less than 3 and x greater than or equal to 3. Both are defined. So we have two numbers, minus 3 and 3. So carefully we'll plot the number line. Minus 3 in the left side, 3 in the right side. Less than or equal to minus 3, this will be the LHL for the minus 3. That is modulus of x plus 3. As it is left hand limit, we will be taking the minus x. Minus x minus 3. Sorry, it is plus 3. And for minus 3 to 3, we have the function 2x. This is the right hand limit for minus 3 and left hand limit for 3. Okay. For x greater than or equal to 3, we have the right hand limit, that is 6x plus 2. Let us do the function. So at x is equal to minus 3. Left hand limit x tends to minus 3. Don't get confused with power, this minus and minus. We represent this power that it is LHL, that is left hand limit, right hand limit, etc. Okay, not with this number, you should not get confused. And the function is modulus of x plus 3. Modulus x, as it is left hand limit, will take the minus x plus 3. So limit x tends to minus 3 power minus x plus 3. So minus already it is there. In place of x it is minus 3. So minus into minus it is plus. 3 plus 3 is 6. Right hand limit x tends to minus 3 power plus, and the function is 2x. So limit x tends to minus 3 the whole power plus 2x. In place of x it is minus 3. We get minus 6. Sorry, I forgot this minus sign. So it is minus 2x. I'm so sorry. The whole minus is there. So minus of minus, it will become plus. And f of minus 3, as I mentioned earlier, check with less than or equal to or greater than or equal to. So we have less than or equal to minus 3. That function only we need to choose. That is modulus of x, that is modulus of minus 3 plus 3. For the number, when we take the modulus, it will be plus. So 3 plus 3 is 6. Therefore, LHL limit x tends to minus 3 the power minus f of x equal to limit x tends to minus 3 the power plus f of x equal to f of minus 3. Therefore, the function is continuous at x is equal to minus 3. Then at x is equal to plus 3, the same procedure we will be following. Limit x tends to 3 power minus f of x. For 3, the left hand limit is minus 2x. Please be careful with this minus. If you forget at any step, then we might end up with the wrong answer like what I did. So be careful with that. Okay. Limit x tends to 3 power minus 2x. Again see. So you also be careful. Okay. Minus 2 into 3, that is minus 6. Right hand limit x tends to 3 power plus f of x. The right hand limit function is 6x plus 2. So limit x tends to 3 power plus. Function is 6x plus 2. Let us substitute x as 3. So 6 into 3, 18 plus 2, 20. The values are not same. The LHL and RHL. Since LHL is not equal to RHL, the function is not continuous, you can mention, or discontinuous at x is equal to 3. The function is continuous at x is equal to minus 3, discontinuous at x is equal to 3. Question number 8, we need to find the point of discontinuity. What we do is, here like the previous question, we don't have less than or greater than, not equal to and equal to. Draw the number line. This is just for your reference, not a compulsory part, the number line part. Okay. For 0, not equal to 0 means both the LHL and RHL, the function remains the same. Modulus of x by x, modulus of x by x. Okay. At x is equal to 0 alone, the function differs. Okay. Let us do the question. Left hand limit, and before that we will simplify this modulus. Okay, so modulus x by x, only for the numerator we need to do, the value is 0, inside we don't have any number, so then that will become x by x. If only for numerator you check, denominator is same. Okay, this will be positive if x is greater than or equal to 0, and this will be negative if x is less than 0. That is, when we cancel, this will be 1, this will be minus 1. That is 1 if x greater than or equal to 0, minus 1 if x less than 0. That is for the left hand function, right hand function. Okay, left hand limit, limit x tends to the number 0, so 0 power minus f of x. So limit x tends to 0 power minus, that is left side, that is less than. So we have the value minus 1. We don't have any variable to substitute the x value, just straight away the answer. Same way for RHL, limit x tends to 0 power plus f of x, limit x tends to 0 power plus, that is the RHS, the same modulus x by x, but when we simplify, the value is plus 1. We don't have any variable, so the value is 1. When you check with the values, LHL and RHL are not equal, therefore the function is discontinuous at x is equal to 0. F of x equal to x by modulus x if x less than 0, minus 1 if x greater than or equal to 0. Like the previous question, only for the less than value. First we will draw the number line, minus infinity plus infinity, the value given is 0. For left hand, that is less than 0, we have the modulus function, you can write it as left hand. For right hand limit, the function is minus 1. Okay, for modulus we will just simplify the same value. Again you need to write it here, I am just saying by showing here. This is for the left hand limit, that is for x less than 0, we have simplified, isn't it? Either modulus x in the numerator or denominator, the same answer we are going to get. X by minus x or minus x by x, it means the same, so minus 1. But you need to write it here now again. Okay, so left hand limit, limit x tends to 0 power minus f of x equal to limit x tends to 0 power minus, the function is x by minus x, that we have simplified, it is minus 1. We don't have any variable to substitute, so the value is minus 1. RHL, the function is minus 1. Limit x tends to 0 power plus f of x equal to limit x tends to 0 power plus f of x is minus 1. We don't have any variable again, that will be minus 1. As these values are equal, we will just use f of 0. We need to check where this equal to is there, greater than or equal to. So the value is minus 1. We don't have any variables to substitute, so the answer is minus 1. As all the three values are same, the function is continuous at x is equal to 0. Number 10, f of x equal to x plus 1, x square plus 1, when we have greater than or equal to 1. So 1 we need to represent on the number line. Minus infinity plus infinity, 1 less than 1, we have x square plus 1, the LHL, greater than 1, the RHL, we have x plus 1. Okay, as you should. Left hand limit, limit x tends to 1 power minus, we have the function x square plus 1. So limit x tends to 1 power minus x square plus 1. Let's substitute 1 value there. So 1 square is 1, 1 plus 1 it is 2. RHL, we will be substituting the function x plus 1. So limit x tends to 1 power plus f of x equal to limit x tends to 1 power plus, in place of function we have x plus 1. When we substitute the value 1 plus 1, it is 2. The values are same. Then for f of 1, check with the equal to. So we have greater than or equal to, that is x plus 1. So that is x is 1, 1 plus 1, 2. All the three values are equal. Therefore the given function is continuous at x is equal to 1.